I chose 1, 1, 2, 3, counting things so easily. Add a 0, now we see whole number grow endlessly.
Negatives count cold like ice. -5 degrees don't feel so nice. Integers stand strong and tall. No fractions here, no cuts at all.
Rational numbers divide with care. 1/2 remains, it's always there. While 1/3, 0.75 comes to a stop, while 1/3 repeats, it never drops.
Irrationals don't play by the rules. Squares have 2 and pi unpredictable tools. They never end, they never align. Infinite digits, no design.
In Egyptian, Thales took a stand. With shadows and light, he measured the land. A stick, a shadow, the ratios tight. Triangles told him the pyramid's height.
If lines are parallel, then hear the claim. Proportion in the triangles are always the same. From shadows to math, he made it clear. Thales the wise, a pioneer.
Small over big, the lengths align. Proportion that fit like a perfect design. No laser, no adorn, just sweet song and chalk. Thales drew truth from a simple walk.
Shadow and stick
in the bright sunlight. Thales found height by ratios might.
Geometry dawned with his simple sight.
You, Thales, you think a bit right, but your basic theorem minds out are right. You talk about ratios last night, I guess, but when it goes to real math, I'm the one they bless. You cut two lines, you draw triangles, but my Pythagorean theorem are the rectangle. A square plus b square is equal 6 squares, that's the law, but in my rectangle truth will leave you in O.
Pythagoras, you're stuck in your right angle view, but I've got the theorem that's way more true. You think your squares make you the champ? I've got proportion that will leave you in a stamp. I prove the ratios, the lines in place. I'm the first to link the angles with grace. You think you're clever with your Pythagorean rule, but my theorem's universal. You're just a fool. I said if two lines are cut, here's the key. The ratios are equal, can't you see? I map the world with geometry's grace, while you're still stuck in your triangle space.
Oh, Thales, you think you're on the top, but your theorem is little too soft. We play with lines and super proportion, but I'm here with real geometric portion. I show you the power of angle precise. Your segments are basic, I roll the dice. You can match my theorem's elegance. My square rules the math is pure brilliance. A square plus b square is the true key, while you just split lines instead of.
Nice try, Pythagoras, but you're just confined. Your theorem is one-dimensional. It's blind. I proved the ratios in triangles, bold. I laid the groundwork for the math we hold. You think your squares are the phenomenon, but I showed how ratios rule over all. My theorem is the bridge between the parts, while yours is just one angle that starts. I've got the general rule, the universal link, while you're still stuck with a narrow thing.
Quadratic in the zone. Parabola up and down it go. It's square in the game, let's go. Second degree, what's the move? X square make the cube so smooth. A, B, C, that's the crew. Plug them in, find the view.
If A is big, U goes high. If A is small, flip the sky. Axis is minus B over 2A, that's the key. Vertex high, vertex low, that's how a parabola goes. B squared minus 4AC, check the roots and let's see.
Parallel up, make it drop, roots unlock, find a spot, 1 or 2, maybe none. We snag, then we done. Factor fast or use the quad, not that hard, not that hard. Parabola, see the shape, parabola up, no mistake.
Circles bold, no edges to see, a perfect curve, symmetry.
Squares stand strong, equal and tight, 4 same sides, left and right.
Rectangles stretch, short or long, 2 sides weak and 2 sides strong.
Triangle points sharp and tall, 3 straight sides, that is all.
Rhombos are still but stay upright, 4 equal sides, always right.
But the heure is hard to define, a complex curve, 2 straight lines.
This can only happen in a triangle. Not only that, but it has to be right angled. If you add the square of the sides A and B, you get the square of the hypotenuse C. 3 and 4 and 5 are the Pythagorean triplet. If you have them as sides, then you can make it. In a square, it can be used, as the diagonals are themselves hypotenuse.
This can only happen in a triangle. Not only that, but it has to be right angle. But flip it around, take a new view. If c squared is at a squared plus b squared 2, then a triangle, just a fake, no right angle, big mistake. And what if we start from the end? If c squared equals a squared plus b squared, my friend, then right away, no need to guess, a right angle, nothing less.
Next time you have a right angle in sight, remember the words that prove it right.